Well, this video is for Math 116. This is on section 1.4 in the textbook about function transformations. So I think, well, first off, there's the three major types of transformations that we'll take a look at are vertical and horizontal shifts, reflections over the x-axis and reflections over the y-axis, and then horizontal and vertical stretches. That's the word I'm looking for. So this topic is kind of interesting. There are some mathematicians who view all graphs and all functions as transformations of a standard function. Okay? So like a standard linear function would be y equals x. And then every other line could be described by transformations to this line. For example, a shift up would make it, let's say we did y equals x plus 2. Then that would be shifted up 2 places. Okay? Let's see here. What else? Same thing with parabolas. The standard parabola is y equals x squared. And we can shift it up or down. Let's shift this one down. X squared minus 5. We'll move that down here. And it'll look like that. Okay? And we can move it over here. We can stretch it out and squeeze it and make it smaller and reflect it upside down. There's all different things that you can do to these. So, you may at some point, if you continue to take mathematics, run into a professor or mathematician who describes all functions as transformations of a standard function. So it's a good topic to be familiar with. It's not absolutely necessary, but I think it is a good thing to think about. Okay, and there's a lot of other things that you can do with functions as well. Okay. And we'll look at some of those in the next couple of sections. Well, let's get started with the transformations themselves. So first off, I've got this standard function that I'm working with that's just made up. Let's see, I'll draw a picture of it here. Okay, and then I'll put a table of values for it over here. So let's see here. We've got the point. Oh, here's the table of values. This is a good one. Negative 6, 0, negative 3, 6, 1, 6, 3, 4, and 8, 4. All right, so negative 6, 0. Negative 3, positive 6, positive 1, positive 6, 3, 4, and then 8, 4. Okay. So there's what the function looks like. There's the table of values. And so the idea here is that we call this f of x. And if we wanted to do f of x, and that's the same thing as y over here, if we wanted to do f of x plus 2 or f of x minus 2, the x values would all stay the same, but the corresponding y values would then have 2 added to them. So if we put f of x plus 2 here, then this will be 2, 8, 8, 6, 6. And so that'll just push everything up 2 places. And it'll look something like that. Okay? And you can do the same thing with f of x minus something. And it's going to just subtract from all these y values, and it's going to push the graph down. Okay? So I think that's one of the simplest transformations is the vertical shift, up or down. You're adding on to the y values, which means that you're adding on to the f of x. And I'll call this f of x plus 2. Okay. first idea there. Next is the horizontal shift. So let's see here. Well, let's look at, let's erase this for a minute. Take this out of here. Okay. Now, what if we were to do something, well, we'll consider f of x plus 2 and f of x minus 2. Notice how these changes, the transformation is happening inside the parentheses. That means it's going to affect the x values, okay? All right, so we know that these y values are dependent on these x values, okay? So we know that this x value of -6 produces a y value of 0, and so on for each of those points I've got there, all right? So here's the thing, is that if we're looking at one of these things, these values have to match up, all right? So we make another table of values. If we call this x plus 2, then f of x plus 2, we'll put these same values in there. 0, 6, 6, 4, 4, right? Because when we plug a -6 in here, it gives us a y value of 0 and so forth. So that means that our original value of x must have started out here at -8, so that x plus 2 would be -6, okay? And then when we take the function of x, or f of x plus 2, that'll give us the 0. And same thing here, 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 and here, okay? So what that does to our graph then is now instead of -6, 0, it's -8, 0. And then -5, 6, -1, 6, and then 1, 4, and 6, 4. And so there's your graph, and it's shifted horizontally to the left. Notice that it goes in the opposite direction of that sign, okay? And that has to do with this scenario right here. So that's f of x plus 2. If we did f of x minus 2, it would shift to the right, okay? We'll put these values in here along with the y values. And now the x that would give us an x minus 2 equal to -6 would be -4. And all of these would be corresponding. And then if we went to graph it, it would just be shifted 2 places to the right, okay? So the horizontal shift happens inside the parentheses, and it shifts opposite in direction to that sign. This will shift to the left, this one will shift to the right. All right. Well, there's the horizontal shift. Let's take a look at the reflections. Well, I'll just erase that. Okay. Now let's draw our standard function again. So we started out -6, 0, -3, 6, 1, 6, 3, 4, and 8, 4. All right, so there's our function again. Now, for a reflection, let's go back to our table of values here. And here's our y values, or our f of x values. What if we negated all of those? Well, that one would stay the same, but these would all turn negative. Okay? And what that's going to do is that's going to flip this over. And it's going to look like this. So when you negate the function outside of the parentheses, that reflects it over the x-axis. Okay? If you negate it inside the parentheses, okay, and just like we did with the horizontal shifts, if we're going to negate this inside the parentheses, we're going to have to set this up a little bit differently. F of negative x, negative 6, negative 3, 1, 3, 8, 0, there we go, 6, 6, 4, 4. But if these are negative x's, that means our positive x's must have started out like this, okay? And so what that's going to do with the negative inside the parentheses is that's going to flip this thing around and it's going to reflect it over the y-axis, all right? So there's our 6, 0, and then 3, 6, negative 1, 6, negative 3, 4, negative 8, 4, and there is our function reflected across the y-axis. And this negative inside the parentheses is what does that, okay? So let's see. So we've talked about vertical shift, horizontal shift, and reflection. Okay? All right. Now, we've got one more kind of transformation to talk about here, and that is the stretching and compressing in both the horizontal and vertical directions. So let's make our function again. Okay, so negative 6, 0, negative 3, 6, 1, 6, 3, 4, and 8, 4. So there's our function. Now, let's see here. If we do a vertical stretch or compress, the way to do that is to multiply the function values by 2. Now notice the 0 is going to stay the same, but these will be 12 and those will be 8. Let's see here. 6, 7, 8, 9, 10, 11, 12. So we'll put 12 up there. All right, so negative 3, 12, 1, 12, and then here 6, 7, 8, and 8. And so notice how the 0 stays where it is, right? So that's not going to change, but it gets stretched. The rest of them get stretched away from the x-axis. And let's say you had a function that looked kind of like this. So these points, if this is f of x, let me do a little sketch of 2f of x, 2 times f of x. This is going to get stretched. All of these are going to get doubled. Then it'll come back to 0, right? And then all the negatives get doubled, and then it comes back to 0, and then the positives will start getting doubled again. So that's what a stretch looks like on a regular curve kind of function. This is the basic idea right here. Okay, so that's a 2 outside of the parentheses. That's going to stretch it in a vertical direction. Notice that everything that's outside of the parentheses affects the y values. When you go inside the parentheses, that's where the x values get affected. Okay, so let's take a look at that one. Let's say we did f of 2x here. Okay, well, just in the same way that we made these, oops, those are y values. There we go. Negative 6, negative 3, 1, 3, 8, 0, 6, 6, 4, 4. Okay, so that means that our x value here must have started out as negative 3. This one negative 0.5, this one a half, 1.5, and 4. So if x starts out as 4, then 2 times x is 8, and we know that f of 8 is equal to 4. Okay, that's how this table gets set up. All right, so now we go to negative 3, 0, negative 1.5, and 6. Positive 0.5 and 6, 1.5 and 4, and then and there is our compressed function, horizontally compressed. Now notice the 2 causes it to get smaller. If we put a half in here, that would cause it to stretch out. Okay? So those are the basic ideas, and this is the last thing here, stretching and compressing. And notice that in each of these transformations, these two are really grouped together. Okay? In each of these transformations, you've got something happening outside the parentheses, and here that's the vertical shift, or the reflection across the x-axis, or the vertical stretching. That all affects the y values. And then when you have something happening inside the parentheses, that causes a horizontal shift to the opposite of the sign, right? The reflection causes it to reflect across that y-axis. And then the stretching and compressing also affects it horizontally, but again, opposite, or the reciprocal of whatever number is in there, right? If we put a fraction in there, 1/3, 1/2, or so forth, that would stretch it out. The bigger this number gets, the more compressed it's going to get. Okay, so those are the basic ideas for these transformations. So let's go and take a look at some of the problems in this section. Okay, let's see. So problem 2 is a good practice. This is what the quiz problem will look like. It's not quite as long as this. It's a little bit shorter, but it is. It's matching one of these things to a description of what it does. Okay, so let's see what we've got here. I don't know whether you prefer to write down the function and then match it to the description, or you want to look at the description and then try to find a function that matches it. Whichever you choose to do is up to you. Oops, forgot my y equals here. Y equals f of x minus 1. Okay. So what I'm going to do is I'm going to write down each one of these functions. I'm going to analyze it and then look to match it up with the description. Okay, like I said, you don't have to do it that way. I think that is just going to work best for me in terms of making this video. Okay, so remember, if you're working inside the parentheses, this is going to be a horizontal shift. It's going to affect the x values, and it's going to be opposite to this sign. Okay, so this should be a horizontal shift. It should go to the right one place. Let's see if we can find that here. Shift right 1 unit. Number 3. All right. Let's cross that one out. It's good to cross these out so that you know which ones you've used and which ones you haven't. All right. Letter B. Y equals f of x minus 1. So now we're outside the parentheses. That's going to affect the y values, okay? And it's going to go in the same direction as this sign. So this should go down 1 place. There it is, number 6. And then we'll cross that one off. Okay, C is just the opposite. This is going to shift up 1 place, 1 unit. Where is that? Shift up 1 unit. Number 9. Okay. D, f of x plus 1 inside the parentheses. Okay, so that's the opposite of this one. Okay, so this is going to shift left 1 unit. Where is that? Shift left 1 unit. That's number 1. Okay, where are we? E, f of negative x plus 1. E, f of negative x plus 1. Okay, So in terms of what happens first, sometimes it doesn't matter, sometimes it does. So it's good just to be aware of the fact that these things are they're affecting the graph, they're affecting the function in a similar way to the order of operations. What's happening inside here is going to happen first to our x values, okay? Anything that happens to the f of x itself is going to happen next. Like if there was a 2 out here, then that would happen next. This vertical shift is going to happen last, okay? So what this is going to do is this is going to reflect it across the y-axis. It's going to switch the negative x's with the positive x's. Then it's going to get pushed up one place, okay? So let's see if we've got that. Reflect over the y-axis and then shift up 1 unit. That is number 10. Right. F, what do we got here? F of negative x minus 1. Okay. Well, that's going to be the opposite. Well, it's still going to get reflected across the y-axis, but then it's going to shift down 1 unit, and that's going to be 11. Okay. And then we've got g negative f of x plus 1. Okay, so this negative f of x, again, that's going to happen before the positive 1 affects it. It's going to reflect it over the x-axis and then shift up 1 unit. Reflect over the x-axis, shift up 1 unit. That's number 4. There we go. Okay, h negative f of x plus 1. Negative f of x plus 1. So remember, we want to start inside the parentheses first. So this is going to get shifted to the left 1 unit. Then it's going to get reflected over the x-axis. So let's see here. Shift left 1 unit. Reflect over the x-axis. Okay, I think that's going to be number 2, and I don't think the order matters here. So let me answer this, okay? And then let's take a look. We'll use our standard function that we had here that was something along the lines of this. And let's do these in both orders, and we'll see whether or not it makes any difference, okay? Because like I said, sometimes it makes a difference, sometimes it doesn't. So let's see, if we reflect first, then we'll get something like this, and then shift left 1 unit, it'll be here. Okay. Alright, now what if we shift left 1 unit first? And then reflect it over the x-axis. You can see, or I hope that you can see, that we're going to end up with the same thing. So in this one, the order didn't matter. Okay? But like I said, in some of these, it does make a difference. So where would it make a difference? Let me give you an example here. Is where you would do something like negative f of x plus 2. Okay? So let's say we had this one. So here's our sample function. Looks like this. Okay, so if you follow the order of operations, you want to do the reflection first. So negative f of x would look like this. And then plus 2 would shift it up 2 places. Oh, yeah, like this. And then there, 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 and there. So there's negative f of x plus 2. Now, if we shifted this one up 2 places, like that, and then reflected it, it would come out down here. That's different. Okay? So, this is an example of a place where it does make a difference. You have to do this reflection first before you shift it up or down. Here, we would end up with the same thing. So, that's why number 2 does match with H. Okay. I, negative f of x minus 1. Negative f of x minus 1. So this should reflect, let's see. Negative f of x, that's going to reflect over the x-axis and then go down one place. Reflect over the x-axis, shift down 1 unit. That's number 5. Okay. Coming to the end here. J is going to give us f of negative x plus 1. F of negative x plus 1 plus 1. And then k is going to be negative f of x. Oh, negative f of negative x. Interesting. And then plus 1. All right. Let's see here. Shift left 1 unit. Let's see. Reflect over the x-axis, reflect over the y-axis, shift up 1 unit. K matches up with number 7. J is a little bit tricky. So it's nice that we leave it for last. So this is 8. And 8 says shift left 1 unit, reflect over the y-axis, and then shift up 1 unit. Well, that's kind of a tricky one. Let's see here. Shift left 1 unit. So that's good. That's the plus 1 there. That's going to shift it left 1 unit. But this is going to get reflected then over the y-axis. And that may be an issue of order that is similar to this one right here. Okay? Let's see. If we let's take our function here and look and see. So if we shift left like this and then reflect over the x-axis, we'll wind up, let's see, with something along these lines. And what if we reflect first? That would give you this. And then shift to the left. That would be different. Huh. This is a tricky one. We can spend a lot of time talking about this, and I have in the past. But I'm pretty confident that this matches up with problem 8. We can think about it some more. One thing that I've done in the past that helps me to see how this one works is instead of looking at it like this, I think about it as I pull that negative sign, I pull that negative sign out here and make this negative x minus 1 plus 1. And then we can make a table of values and play around with it, again, which I've done in the past, and that's why I'm pretty sure that this one does match up with number 8. But like I said, it's kind of tricky, and you can think about it for a while as to how this is all happening. Okay, let's move on and look at a couple more problems here in section 1.4. All right, so problem 4, this is on page 31. We've got a picture of f of x. And the key here are these points that I've identified on the function. Those are the key points here. So negative 8, 7. I'll make a little table here. Negative 8, 7. Negative 4, 7. Negative 2, 4. And 6, 4. Okay. Negative 4, 7. Negative 2, 4. And 6, 4. So we get a function that looks something like this. And then the problem asks us to find, let's see, f of negative 3, negative f of x plus 2, a half of f of x minus 1, and then d f of negative x plus 1. Okay. So for starters, A, f of x minus 3. That's going to shift this 3 places to the right, and so then we're going to have negative 5, 7, negative 1, 7, positive 1, 4, and 9, 4. Okay? And it's a good idea to label these. 1, 4, 9, 4. So then we know what's happening here. Okay? All right, B, negative f of x plus 2. All right, so that's going to reflect this over the y-axis and then shift it up 2 places. So, reflect this over the y-axis. It would look something like, something like this, okay? And then shift it up 2 places. So this is negative 7. So this would be negative 8, negative 5. And then here, negative 4, negative 5. And then what? Negative 2, reflected it would make it negative 4, shifted up 2 places, negative 2. Negative 2, negative 2. And then over here would be 6, negative 2. And so there it is like that. And this was just that intermediate sketch that I did for where it was reflected over the x-axis. And this is negative 4, negative 5. All right. C. All right, so this is going to shift to the right 1 place. So this will be negative 7, negative 3, negative 1, and 7. And then all those y values are going to get cut in half. So let me make another table here. Negative 7, negative 3, negative 1, and 7. And then all the y's get cut in half. 3.5, 3.5, 2, and 2. All right, so negative 7, 3.5, negative 3, 3.5, negative 1, 2, and 7, 2. And so there it is. Okay, so it's shifted to the right, and then it's also scrunched down, right, because it's 1/2 on the f of x. And the last part, D, let's see what's going to happen. This is going to get reflected across the y-axis, and then it's going to push up 1 place. So these will be 8, 4, 2, and negative 6, and then these will be 8, 8, and 5, 5. Okay, so 8, 8, 4, 8, 2, 5, negative 6, 5. And I didn't label these points because I made a little table. You can do either one. You can label them, or you can draw it with a table next to it, and I think that's the best way to do these problems. Okay, let's see here. Let's look at problem 6, and that'll do it for section 1.4. Okay. All right. So we're going to need a new setup here for problem 6. Here's our graph. What do we have here? 0, 3, negative 4, 3, negative 2, 6. Like a little semicircle there. And I'll put those in the table here. Negative 4, negative 2, and 0. 3, 6, 3. And what are we interested in here? F of x plus 2 be negative f of x minus 1. C, f of x minus 1 minus 3. And D, 1/3 of f of x plus 4. Okay, First one's pretty straightforward. Everything just gets pushed up 2 places. And so then we've got -4, 5, 0, 5, and -2, 8. Okay. Part B, this is going to get shifted to the right 1 place, and then it's going to get reflected over the x-axis. Okay, so we're going to have 1, and then instead of 3, it's going to be -3. And then we're going to have -1, and instead of 6, it's going to be -6. And then instead of -4, it's going to be -3. And instead of 3, it's going to be -3. So -3, -3. And there's our little semicircle. Okay. F of x minus 1 minus 3. So that's going to push it to the right and then down 3 places. Okay. So again, let's see. If we start out here with the 0, 3, that'll push it over to 1. This will push it over to 1. And then this will push it down to 0. So 1, 0 is going to be right there. This point right here, -2, 6, it's going to go over to -1 and then down 3 places to 3. So -1, +3. And then the last one, -4, is going to go over to -3 and then down to 0. And there's our little semicircle. And the last one, 1/3 of f of x is going to cut all these, divide all of them by 3. So it'll be 1, 2, and 1. But then we're going to add 4 to them. Okay? And this is all in the y values. So we're still going to have this x value of -4. But then this will be 1. And then add 4 to it will be 5. So that'll put it up here at 5. -4, +5. This one gets divided by 3 to become 2. 2 plus 4 is 6. So notice how this distorts the shape of that little semicircle. And then this one again. This one will be in the same place as this one. Divide it by 3 to get 1. Add 4 to get 5. And then you get this little semicircle up there. Okay. Well, that was kind of fun. This is kind of a tricky topic. We can make it as simple or as complicated as we want to in, kind of analyzing how these things all happen. So I think I've got a pretty good collection of problems in there. Those matching problems work pretty well. These sketching problems I also think are very helpful to help you to think about what's happening across the coordinate axes when we're talking about functions. And if you have any questions on these, please let me know. Thank you.